Okay, so now we're on page number 2, question number 3. It says graph the segment that connects the points A, -4, 8, and B, 6, 3. So first I'm going to put X and Y on my axis, and then think about these as X and Y, and then start graphing. So I'm going to -4 on the X, so that would be right here, and then up to 8 on the Y. So that would be up there. Oops, so sorry. Let's see here. So that is going to be right here. And then 6, 3 would be here. Make sure you're labeling those points. That's going to help you out. And then I'm going to connect those dots. Okay, then it asks for the slope of that line segment. So we're going to say rise over run. So we're going to count it. I'm going to count, I'll use a different color here and we'll zoom in. So I'm going to count the rise, which is 1, 2, 3, 4, 5. I like to start from the bottom point always. I just think it makes it easier. And the run is negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -10. So 5 over -10. But we want to do a couple of things here. We want to think about the fact that this will simplify. So if I type it into the yellow calculator, it will simplify to -1/2. And then also think about the fact that that negative here can be on the top, the bottom, or in the middle. It represents the same thing. So then the next part, it says, what is the length of AB? So we're thinking of Pythagorean theorem. So I actually have this little triangle going on here. If I think about this as like a right triangle. So then I'm looking for this length, and I already have that this is 10 long. If I'm thinking about length, it's going to be positive, and this is 5 long. So I can do Pythagorean theorem here. That's where you kind of have to be careful because we used a negative on part A, but on part B we didn't have to. So 5 squared plus 10 squared equals c squared. So 5 squared is 25, 10 squared is 100, and then equals c squared because we want to square all the things before we get to the next step. So then we're going to add the 25 plus 100, so that's 125 equals c squared. And then we're going to take the square root of both sides to get c alone. So c equals, and it has no rounding rules, so I'm going to go at 3. 11, oops, oh darn. There we go, sorry, 11.180. All right, and then part C, it says write an equation for the line that connects those points. So we want to write into y equals mx plus b. So we already have our slope here, which was -1/2. So that was up here, so -1/2 x. And then we want to know where it hits the y-axis, that's the b. So we're going to count this and make sure that we have it counted right and see the exact point. So it looks like it hits at 6, but we want to make sure that that's perfect. So we're going to go 1, 1, 2, 1, 1, 2, 1, 1, 2. It does hit perfectly at 6, so we're going to write that 6 there. Sometimes it doesn't hit perfectly, and then we'd have to do some other things, but this one worked out for us. So then part D, it says write an equation for the line that is parallel to AB. So just like on the front, to make it parallel, it has to have the same slope. So all we need to do is make sure that we're using that same slope. And then it really doesn't matter what you use for your B. So you can put any number there. I put a blank on the answer key, but I'm going to just put a 1 there. So anything there, the only thing I wouldn't recommend putting there, is a 6, because then that would make it the same exact line as the one before, and we don't want that. Then part E, it says write an equation on the line that is perpendicular to AB. So perpendicular, just like the front, would be opposite reciprocal slopes. So you're flipping and changing the sign. So if my original slope was -1/2, we flip it, so now it's 2/1, and then change the sign, making it positive. So I'm going to write 2/1x, and you can write it as just 2x, and then plus or minus whatever number you want to use. And I'll just use 1 again. And on the answer key again, there's just a blank spot because there's a lot of options here. So then on number 4, it says identify the geometric angle relationship in each diagram. Use what you know about those relationships to write an equation and solve for x. People forget that a lot, so it's really big. So you'll want to use your toolkit here on this one. So looking at this, these are the same angle the same angle locations at different intersections. So that would be called corresponding angles. And we know those lines are parallel, so we know that those angles are equal. So the relationship is equal. You can also write congruent. And the equation we're going to write here is x plus 15 equals 102. And then we need to solve it. So to get x alone, we're going to take away 15 from both sides. So this is a quick one, but we're still going to show our work so we have the opportunity to corrections later if we want. So that would give us 87. So then on part B, those are considered vertical angles because they're across from each other. So we're going to write vertical angles. And the relationship is that they are equal. You can also write congruent. And we're going to set those equal. So x plus 21 equals 7x minus 3. So now we're solving for x here. So I'm going to avoid negatives. There's a lot of ways to start this, but I'm going to set it up so I get that x on the other side. So I have 21 equals 6x minus 3. And then right now the 21 is alone. So I'm going to move things that are like it over to it, which is that negative 3. I'm going to add it to move it to the other side. So now I have 6x on the right side, and the left side is 21 plus 3, which is 24. Then our last step to solve for x here would be divide by 6. So we get 4.